Okay, so for our second proof problem, we have here two triangles again. Given we have triangle TAO or triangle Tau and triangle OAH. And also another given is we have line segment TO is also congruent to line segment OH. And point A is the midpoint of line segment TH. Okay, so we want to prove that triangle TAO and triangle OAH are congruent. Okay, so how do we do that? Okay, given our givens here above. Okay, so first we can state our givens here. So that's always kind of like the first part. Okay, so we can write here. Okay, so we can write here that TO is congruent. Okay, is congruent to OH. So that's a given. So the reason for that is a given. Okay, and after that, what do you think, guys, is the second? What do you think, guys, is the second statement? Okay, so we can try to state that. Okay, we can try to state that AO is congruent to AO. So how do we say that those two segments are congruent? So it's simply because of the reflexive property of congruence, or the reflexive property of equality also. Okay, so AO is congruent to AO because of the reflexive property of congruence. And then we have the third one. Okay, so we can state here that, that point A is the midpoint of TH. Okay, so it's the midpoint of TH. That's because it's given. Okay, so it was written here on the information given above us that it's a given. Okay, so what do you think, guys, is the fourth statement? Okay, so the fourth statement that we can write here, okay, can be simply written as TA. Okay, TA, a line segment TA is congruent to segment AH. So how do we say that? How can we say that? Well, since point A is the midpoint of TH, then we can say that point A kind of like bisects, or kind of like is the half. Okay, it's the midpoint, and therefore it's the half. It divides line segment TH into two congruent parts, which is line segment TA and line segment AH. Okay, so therefore we can say that TA is congruent to AH based on the definition of a midpoint. Okay, so we can write here definition of a midpoint. Okay, so that's how we write our proofs using electronic devices. Okay, so it's very good that we have this computers and laptops to help us. Okay, so that's very nice. Okay, before we try to use paper and pencil. Okay, but you still can use paper and pencil, guys, if you are very used to that. But it's also much faster if you try to use our laptops or our electronic or digital devices. And then lastly, we can now confidently say, or logically say, that triangles TAO and OAH are congruent. So how can we say that both of those triangles are congruent? Based from the side triangle congruence postulate. Okay, so that's simple. Okay, so how did we say that? Okay, so we've proven already. Okay, guys, we've already proven, or it's given, okay, that TA is congruent to HO, and by reflexive properties, so AO is congruent to AO, which is the side that both those triangles share, and also TA is congruent to AH, and therefore based from the side triangle congruence postulate, we can say that triangles TAO and OAH are congruent. Okay, so next we have the side angle side triangle congruence postulate. Okay, so simply states that when the consecutive sides and the included angle of one triangle is congruent to the two consecutive sides and the included angle of the second triangle, then both of those triangles are said to be congruent. So for example, we have here triangle PZM and triangle GZE. Okay, so what do we mean by consecutive sides? So it means that those are the sides that come together in order. Okay, so in order we have here TZ and ZM. Okay, so those are consecutive sides, and we also have GZ and ZE. Okay, so if these two consecutive sides, okay, these two pairs of consecutive sides are congruent, and the angle, the included angle, so when we say included angle, it means that it's the angle inside of those two consecutive sides or rays or lines. Okay, so it says that if these two angles are congruent, then we can say that the two triangles themselves are congruent based from the SAS congruence postulate. Okay, so we're going to try to write a paragraph proof, okay, for this problem. Write a paragraph proof that proves that triangle TZM is congruent to, okay, triangle TZM, okay, triangle TZM is congruent to triangle GZE. Okay, so before writing that proof, so we want to try to define a very critical terminology, or one of the cool terminologies that we have here in geometry. So it's the QED. Okay, so QED is a Latin, it's a kind of like a Latin acronym for like an ending of a proof. Okay, so we call it as the okay, so QED simply means quod erat demonstrandum, or simply, if you translate that to English, that which was to be demonstrated. So we simply write that at the end of a paragraph proof. Okay, so QED, or any two-column proof if you want, but it's not really necessary for a two-column proof. But for a paragraph proof, it's kind of like important to write QED, so that signifies that our proof has reached its ending, or we've already proven what we wanted to prove. So we write QED, okay, QED after that, or we can simply write a very specific symbol for that. So it can be like a square, a shaded square, or it can be like an asterisk, or any symbol that you would like. Okay, so this is the paragraph proof that we have, guys, for this problem. Okay, again, guys, we want to prove that triangle TZM is congruent to triangle GZE. And we need to write a paragraph proof for that, and also include our QED here, what we previously discussed. And we have here our proof. So given that point Z is the midpoint of segments MG and TE, so that's one of the givens here. Okay, so it's one of the givens here, so it's right here. Okay, so point Z is the midpoint of lines MG and TE, of those two lines. Okay, and given that line TZ measures 4 meters, we can conclude that line segment ZE also measures 4 meters, with point Z being the midpoint of line segment TE. Since line segment ZG is congruent to TZ, therefore its measurement must also be 4 meters. Okay, so since okay, so they're congruent. Lastly, since point Z is the midpoint of segment MG and TZ measures 4 meters, therefore line segment MG must measure 8 meters. Okay, so this is one of the conclusions that we can have for this given problem. Okay, so we can say that TE, line segments TE and line segments MG measure 8 meters. And we've written here QED, or quod erat demonstrandum, at the end. So how can we say that triangles TZM and triangles TZM and GZE are congruent? Okay, so since we know that this is the midpoint, okay, this is the midpoint of TE, so we can also say this is the 4 meters, this is also 4 meters, as also what's also mentioned here in the paragraph proof. So this is also 4 meters, since Z is again the midpoint of GM. Okay, so this is also 4 meters. And from the triangle, from the ASA, or from the angle side angle triangle congruence postulate, we can say that TZM, okay, TZM is congruent to JZE. So how is that? Because these are vertical angles again. Okay, so angle TZM and angle GZE are congruent. Okay, so why are they congruent, guys? Okay, so angle TZM is congruent to angle TZE. They're congruent because they are vertical angles. They are one of the special angle pairs that we have. And therefore, since this is a side, an angle and a side that are congruent to this other triangle, so its side, its angle, and its side is congruent to the other triangle, then therefore we can say that these two triangles, we can conclude that triangle TZM or TMZ is congruent to triangle GEZ or GZ. Okay guys, so we have here our third proof. Given triangle SMZ, okay guys, so we have here our third proof. We have here triangles SMZ and triangle ADZ. Okay, triangles SMZ and ADZ. We want to prove that point Z, okay, we want to prove that triangle SMZ and triangle ADZ are congruent. So we want to prove that both of these triangles are congruent, given that point Z is the midpoint of the line segments. So let's jump right ahead with the proof right here. Okay, so we're given here, okay, one of our givens. Okay, so let's change that to black. Okay, so number one. Okay, so number one, our first given is that both of those triangles are congruent. Okay, so that's already kind of like a given. Okay, and point Z, okay, point Z is the midpoint. It's the midpoint of segments SD and MA. So that's a given. Okay, so that's a given. Okay, and what do you think, guys, is another statement? What other statement can we write here that can help our proof? Okay, so we can write here for our statement number 2. Okay, we can write here for our statement number 2. Okay, so 2 we have here, since point Z is the midpoint of SD, then we can say that SZ and ZD are congruent. Okay, so that's the okay, so the reason for that is a definition. Okay, so it's a definition of a midpoint. Okay, so we can simply put that here. Okay, so since we said that SZ and ZD are congruent, then we can also say, okay, we can also say that MZ and ZA are congruent. Okay, since Z is their midpoint. Okay, and that's also again a definition. Okay, a definition of a midpoint. Okay, so we can clean this up a bit. Okay, and then we can write, okay, we can find a third proof. Okay, so we can say, okay, or we can write a fourth statement. So our fourth statement can be angle SZM is congruent to angle, okay, to angle AZD. So why are they congruent? Again, guys, because they are angle pairs or they are vertical angles, and vertical angles are always congruent. So let's write that here for our fourth one. Okay, so we have all of the recipes that we need to finally prove our theorem here, or the one that we want to prove. So number 5, we can say that triangles SMZ and ADZ are congruent based on the SAS, or the side angle side. Okay, they're congruent based on the side angle side triangle congruence postulate. Okay, there you go. Okay, so we now have completed our proof here. Okay, triangle SMZ and ADZ are congruent based on the SAS triangle congruence postulate.